lesson, we're going to start learning about actual molecular shapes. And we're going to be using balloons to show how that works. We're going to start with the previous lesson's instruction on how we use orbital notation to represent the hybridization of orbitals so that this kind of molecular shape can take place. Okay, let's remind ourselves of what we're talking about in the last lesson. We're talking about hybridization. And so we started out with unhybridized sets of orbitals using orbital notation. Let's see, let's pick a fairly simple atom that has both an S and P sublevel. How about fluorine? Okay, so here's fluorine and here's the orbital notation for fluorine. Yes, you probably should be writing this down with me. You know, if I'm writing it down, you probably shouldn't at this point in the semester be asking me, should I write this down? If you need it, you write it, okay? If we do go through what's called Sp3 hybridization, so what we're going to do with Sp3 hybridization is we're going to take the S orbital here and the P orbital in the highest primary energy level. If we had a third energy level, that would be 3s and 3p. If we had a fourth energy level, it would be 4s and 4p. But right now, we're using a simple atom with only a 2s and 2p. We're going to take one s and one set of 3p orbitals. So that's where we get sp3 from, 3p orbitals, p3. So we're going to take all of these and we're going to hybridize them. So 1s remains unhybridized. We don't do anything with that. It's not involved in the bonding, but everything else gets kind of mushed together and we get a new set of orbitals, new shapes, new energy. We call these sp3s. And it's in the second primary level. That's where that 2 comes from. And we count all the electrons in the S and P sublevels we're hybridizing. Actually, we count all the electrons in the S and P sublevels, period, to use in other hybridizations, so let's just say it that way. We count all the S and P electrons in the valence level. The highest energy level is the valence level, and put them in here one box at a time, and go back and share them up as needed to get all the electrons in there. Okay, so now that's an sp3 set of hybrids. So we've hybridized then this set into this set. Okay? Got that? And that's what we're doing in terms of orbital notation. Okay? But in terms of what they actually look like, because this is a kind of an inventory system, a way of keeping up with the number of electrons and where they are, but it doesn't actually show the shape of the orbital. So that's what our balloon models are all about. Okay? So we're starting out with looking at how it is this hybridization occurs. Okay, and so you have a set of balloons for that purpose. All right, so this is what we did previously right here. Okay, set of 4 orbitals, and one of the p orbitals will be these blue balloons here. Okay, one of the p orbitals will be these pink balloons. So an orbital, a p orbital anyway, has 2 nodes. Actually, all orbitals have 2 nodes, but the s orbital you can't really tell. We're not going to get into that too much here in high school chemistry. All right. But and the purple balloons in my model anyway represent the last p orbital. There's 3 p orbitals. Yes. When we hybridize those, not only do we hybridize these p orbitals, we also hybridize the s orbital that surrounds it. So there's an s orbital that's a sphere. Think of a huge clear beach ball that we put these inside of. Okay, that makes sense, right? If we had a clear beach ball and we put all this inside of it, then we'd have an s and p set of valence level orbitals, yes? Okay, all right. What we're going to do then is we're going to take this set right here and we're going to hybridize that. So all the p orbitals get changed in shape and so does the s. So now my green balloon represents whatever the s, so this, we assume that this had a green s orbital surrounding it. Can you see that in your mind's eye? Are you running the movie in your head here? Huh? And so what we have now is the hybridized set. We hybridize them. They change their shape and they change their orientation. They even change the amount of energy involved. So there's our blue balloon that came from the blue set of p orbitals. There's our pink balloon that came from our pink set of p orbitals. It had 2 nodes originally. This actually has 2 nodes. We won't get into it in high school chemistry what it means, okay? There's nothing around it anymore because now this s orbital, which was imaginary in your brain, was green, now is the same shape as the other orbitals, okay? So it's like we got rid of one of the balloons, all right? So let's say that these 2 balloons, these 2 pink balloons were joined together and the air could flow from this pink balloon to this pink balloon, and I squeeze this one down here really hard. What would happen? This one up here would get bigger, wouldn't it? Kind of more heavier, okay? There's actually a tiny little antinode on these things that you can't see, all right? It's actually back here somewhere on the back side of each of these. But what we've done is we simply change the shape, change the orientation, and that's what you have there. It's a set of Sp3 hybrid orbitals in the valence level of whatever atom it is, okay? Remember, even though there may not be electrons in every orbital, the orbital still exists, okay? So you're going to label all of these now as Sp3 hybrid orbitals. Sp3 hybrid orbitals. So now on your notes, you want to draw or redraw that set of unhybridized p orbitals we did in our last balloon modeling activity and include the s orbital that surrounds them, and then draw your new set of hybrids and draw arrows to show how each of those orbitals hybridized. So your p orbitals might look something like this. And I've been doing this a long time, so yours don't have to look exactly like mine. And now we've got a new set. Okay, so this would be the s orbital here. And it doesn't matter which one of these other orbitals you go to, but we're going to change this one into that shape. And this p orbital that's top and bottom here, but I'm just going to say it's this one. And this p orbital here, I'm going to say it's this one. And this p orbital that's front and back here and here, so let's say this is it here, is going to be the one I have over here in the back here. Okay? So this is the hybridization of unhybridized to Sp3 hybridized. Hybridization of unhybridized to Sp3 hybridized. Okay? Now, if you like coloring things, you can color code it and all that sort of thing too. Just like your balloons are actually color coded. Okay? If you've got colors to do it with. It's not a required set of supplies in this class, but you can do that if you wanted to. Each of these p orbitals that were double balloons are now single balloons. Okay? So this p orbital here, left and right, that I'm putting my fingers on right here, became this single balloon in the front.
Oh, so they're just like the problems
Yeah, just like the problems you did, because you're changing one p orbital into something else. Okay? There is technically a little tiny antinode balloon back here that we don't even bother with because it doesn't do anything. Okay, so for right now we're kind of ignoring it, but you know, you may need to know that for college. Okay, you got that? Everybody finished with those models? All right, so how does that equate now to how things actually bond? Well, you can do a lot of different kinds of bonding using this Sp3 hybridization. Okay, we're going to start with, let's see, how about we do methane, because that's kind of simple. Okay, now what we're going to do with methane is, remember when this, well, let's see here. So we've got carbon, and I'm going to show you the orbital notation that has to do with carbon's Sp3 hybridized state, where I have 4 electrons that are in those balloons by themselves. So this could also be an Sp3. This right here could also be an Sp3 for carbon. If it has an Sp3 hybridization, the balloon model you just made represents it. Okay? But I can bond 1, 2, 3, 4 hydrogens here on this carbon. Now, our carbon model, we're going, this is the center, this is the nucleus right here in this carbon model. Okay? Or the fluorine model, or whatever it happens to be. Okay? So, we showed yesterday how hydrogen, when it, if I do, I'm going to put 1s above it here, and we have 1 electron, and so that these 2 orbitals are going to actually join together. Remember that yesterday in our last lesson? Okay, so they're actually joining together. And so what we're going to do is a model of the CH4 we did yesterday, and we're going to show how it uses this. Now what's going to happen is the s orbital in the hydrogen, which is spherical, is actually going to hybridize as well. It doesn't look like it much, so we don't sweat it too much, okay? But what's going to happen is this hydrogen's s orbital, or hybridized s orbital, is going to share the same space with this sp3 orbital from carbon. Okay, and what's going to happen is this orbital, instead of being sort of a round balloon shape, is going to elongate into more of a wiener, hot dog wiener shape. Yeah, like the long balloons you got. Okay, but here's what we're going to do. Now this is going to be a little bit tricky, so pay attention to how I tell you to do this. You need to blow up your long balloon all the way to the end, and then pinch it off and tie it so you got a little round balloon at the very end. You're going to tie a knot right there. And then you're going to blow it up again all the way to the end and pinch it off so you got a hot dog shape like this. Okay? And tie it off right there. And you got this, you'll have a lot left over here. Alright? Now, try to find 4 balloons, long balloons, that match the colors of your sp3 hybridization. Okay? Try to find 4 balloons that match the colors of your sp3 hybridization. Alright. You're trying to make 4 balloons that look something like this. Okay? 4 balloons that look something like this. All of different colors, as much as possible, matching the colors of your original sp3 hybrid round balloons. So if you'll listen, I'll tell you, you're going to blow up the entire balloon to the end, pinch it, twist it, let all the air out, and tie it right here. Then you're going to blow it up again all the way to here. You want it nice and snug up here. And then you're going to pinch it down here, twist it, tie it, let the air out, and tie it off. If you blow up your balloon, you don't have to blow it up all the way. You can blow it up just about like this that I've got here, and then you just start squeezing it. One hand over the other, and you'll watch it. It's going to grow it's going to push that air all the way up to the end. Okay? Once you got the air to the end, then, now you can pinch it off into a round balloon shape. And then you can tie it off right there and have a nice round tip, which is where the hydrogen is going to go on the end of your balloon model. You don't have to blow it all the way up. Just blow it up like this. Okay? I've got a little section about like this all blown up, and now I'm just going to squeeze it with my hands, hand over hand, and move that air all the way up to the tip. Okay? And what I want to do is to have a hot dog shape here. What I want also is to have the shape of or the length of the balloon about the same as the previous one. Okay, so I'll let enough air out as I need it to make it about that same size and shape. Twist it, and then tie it. And you want to have 4 of these, each of a different color, and as much as possible the same colors as your hybridized set of round balloons. Alright guys, when you have 4 balloons like this, then you're ready to tie them all together. And just like our round balloons, we're going to tie 2 of them together at a time, nice and snug together. Okay, now the round balloons were easy to tie snug together. You've got to kind of pull these nice and snug together, okay? Just like when you're tying your shoe, that first half knot, you've got to kind of pull it up nice and tight. Okay? And so what you want is your balloons sitting really close together like this, or even closer than that. And then you put it together, and you've got a methane molecule. We're going to label these. Wouldn't be a bad idea if you took these balloons and just tied one more knot for the sets together just to kind of keep everything together. So I want to clip the pieces of balloon off here. And I'm going to leave one balloon tail just so I have something to kind of carry it around with. Okay, and we got one little balloon here to be able to carry things around with. Okay, I can tie a string on this to be able to keep up with it. Now I'm going to label this. I'm going to show you how to label this. This is a hydrogen, and every one of these things on the tips are hydrogens. Each of these orbitals, each of these bonds started out as Sp3 hybrids. So down here, right where the corner is, where everything's tied together, that's the nucleus of our carbon atom right in there. And so that hybridization is Sp3, and all these balloons need to be labeled Sp3 right at that corner. But we said that these balloons that form from the overlap of hybrid orbitals, so I've got a hybrid orbital coming from the hydrogen and a hybrid orbital coming from the carbon, these make what are called sigma bonds, and sigma bonds, or sigma, is a Greek letter that looks like this. And so you want to label each of these as sigma. Okay? So Sp3 and sigma. Sp3 has to be down near the nucleus where the carbon atom is located, Sp3, and then sigma is labeled up here. Okay, Sp3 and sigma. Sp3, and then sigma's in the middle because it applies to the whole bond. Sp3 and sigma. Okay, so you've got hydrogen on the end. There's hydrogen. Sp3 down here and sigma right there. All right, if you'll pay attention up here, it's important that you understand the entire progression. We started out with a set of p orbitals for which we did not make a model of the s orbital that surrounds it. You have to imagine that this set of p orbitals is inside a round beach ball. Okay, and that beach ball represents the s orbital. And for the purposes of our Sp3 set of hybridization, that beach ball is green colored, because when I get to this model, put this away if I can, there we go, we have p orbitals that became sp3s, p orbitals that became sp3s, p orbital that became sp3s, and the s orbital also became an sp3. Okay? Now, I didn't happen to have balloons of exactly the same shade and color to make my methane molecule, but this is what I have for a methane molecule. Okay? And I put a string on it so you can hear it down the hallway. All right? So, each of those sp3 hybrid round balloons became an elongated balloon when the electrons from the other atom were shared. So the nucleus is right here. Here's the other atom, the hydrogen. And when that round-shaped balloon here shared electrons with this hydrogen, it elongated the shape into this sort of hot dog wiener shape. Okay? And so you're going to label these. You're going to label these to show that sp3, well, it's upside down there. Let's flip it over for you. Sp3 hybridization is right down here in the corner because this is the sp3 hybridization at the carbon atom. Okay? The elongation occurs when the sharing occurs, and then it becomes a sigma bond. Anytime you are sharing electrons between hybrid orbitals, that's a sigma bond. And that bond then is along an axis that extends from the nucleus of this atom to the nucleus of this atom. So it's at a wiener shape, as if you had taken one of those wiener roasters you use at a campfire. You know what I'm talking about? You run through the middle of your wiener, put it over the fire to roast it. And so the axis is where that roaster sticks through that wiener. All right? So we've got 4 axes here, and those 4 axes are at 109.5 degrees apart. 109.5 degrees apart. All right, so we started out with one drawing here of that sigma bond, which comes out of the sharing of electrons between 2 hybrid orbitals, okay? And the result is we get a shape somewhat like this for a methane molecule. And so you've got one bond going up toward a hydrogen, and one bond going out like this at 109.5 degrees. And you've got to know that number, by the way. You've got one that's coming out toward you, and we got one kind of swinging back behind here, and a hydrogen, okay? And then you're going to label all these. This is a hydrogen, this is a hydrogen, this is a hydrogen, hydrogen. Right up here, close to the nucleus of the carbon atom, in this particular case, is an sp3 hybridization. And then sp3 is right down here close. And then what it's forming is when you overlap this hybridized orbital, okay, when they share an electron between 2 hybridized orbitals, we form a sigma bond. And that sigma bond is always directly on a line between the 2 nuclei of the 2 atoms involved, between which those electrons are shared. Is that clear to everybody? Now, so if we start out with carbon's electron dots, I hope you're drawing this out with me on your notes, and we share the electrons, and then we do the Lewis dot formula. And finally the Lewis formula. We did all this yesterday. This is like we took this balloon model here and just flattened it out. Okay, and you could probably take your balloon model and flatten it out and you'll get that. But in fact, in 3 dimensions, it's not flattened out. It forms a shape where we have 109.5 degrees between the axes. And so one of these axes is swinging out toward you, and use triangle to kind of show that, and one of those is going back behind the paper, and we use a dotted line to show that. So the shape of your molecule is actually this. Yes?
Can I get some envelopes in the back? Can you get them
Hold on a minute. All right. Now, here's what I want to do. I want to start with a different molecule now, and that's where I combine nitrogen, which has 5 dots, and 3 hydrogens. Okay, sharing electrons here. Okay, squeezing those electrons in between the atom symbols to make the electron, or the Lewis dot formula. And I've got a lone pair up here, and finally the Lewis formula. Okay, there's nitrogen. I'm sorry, not nitrogen. It's ammonia. I said nitrogen. It's ammonia. Okay. Now, for this model, the hybridized set of balloons here, this single balloon, round balloon, party balloon shape doesn't change its shape because we're not extending it into a bond. So for this model, you need 3 balloons like this. Okay? 3 balloons where you tie a small spherical shape at the end, tie a knot, blow up a 9 or 10 inch section, tie another knot, 3 of those, and 1 round balloon. And then tie all of those together in the middle. You with me? We all understand? Because this is your homework, to make the nitrogen molecule model. Okay? Now, what you do is, you can do one of 2 things. You can bring it in here for me to grade, or you can take enough pictures of it for me to see you've done everything. Okay? So, the round balloon, you're going to label that as lone pair, okay, or unshared pair, because that's what it is. It's an unshared pair. And then all of the balloons like this that we made our methane molecule, we have 4 of them here. You're only going to have 3 for the ammonia. You're going to label them just like we did for this. Okay, hydrogens on the end, sigma bond, Sp3, because it is Sp3 hybridization. Everybody understand what your homework is?
Yes, sir.
To make a model of the ammonia molecule at home and either bring it in for me to grade or take a lot of pictures so that I can see every balloon, every label. Okay, and then you can email those pictures to me. Or I'll tell you what, I will put a document in your Google folder for you to cut and paste. All right? So if you're kind of stuck on how to do the homework, perhaps you should watch this video on my YouTube channel. Unit 3, Sp3 Hybridization is the title of the video. You can simply look it up that way, or you can find this web address at the top of the page here, which is kind of long and a lot of letters and things. I'll try to put a link on this video for you. If you see the link at the bottom, just click that. It should take you to this video. So this video pretty much covers all of the Sp3 hybridization models. At least you'll get a chance to see what the balloon model should look like when it's done. I'm going to pause it here and kind of skip over. And there's the unhybridized set of orbitals. There's the hybridized set of Sp3 orbitals. Still talking about the Sp3 set of hybridized orbitals. Let's see. And that's where we're talking about what the methane or the ammonia molecule is going to look like. At about 550 it appears.